Okay, good morning class. So today we are going to learn about salts, and our group presenting, we are 7 members, and each group will present, each person will present a minimum of 6 minutes. Okay, I will introduce the topic. So a salt is a compound formed when a cation from a base combined with an anion from an acid. So a salt is therefore formed when the hydrogen ion is replaced in a metal or ammonium radical. The number of ionized hydrogen in an acid is called basicity of an acid. A salt is a chemical compound primarily composed of sodium chloride. It is a crystalline substance that is commonly used as a seasoning in cooking to enhance the flavor of food. Salt also plays an essential role in various biological and industrial processes. It is crucial dietary mineral for humans and is involved in regulating fluid balance. Also, it regulates the nerve function and the muscle contraction. There are different types of salts, including table salt, sea salt, and more, each with slightly different characteristics and its uses. So what we are basically saying is that a salt is formed from a reaction between a cation and an anion. What is a cation? A cation is a positively charged electron, and an anion is a negatively charged element. So a salt is formed by a chemical reaction between a base and an acid, and a metal and an acid, a metal and an nonmetal, a base and an acid, an anhydride and a base anhydride, or in the same metathesis reaction where different salts are mixed in water. The reaction between an acid and a base is called neutralization reaction. Salt present in large quantities in seawater is where it is the main mineral constituent. It is essential for animal life, and saltiness in one of the basic human tastes. So some of acidic salts, which are formed by partial neutralization of a diprotic or a polyprotic acid, is known as acidic salt. These salts have ionized hydrogen ion along with another cation. Mostly the ionizable hydrogen ion is part of the anion. Some salts are used in baking. So there is another type of salt known as the basic or alkali salt. This salt is formed by partial neutralization of a strong base by a weak acid. It's known as a basic salt. They are hydrolyzed to form a basic solution. It is because when hydrolysis of a basic salt takes place, the conjugate base of a weak acid is formed in the solution. In summary, a salt is used for various purposes. We have said in cooking, in preserving food, as a condiment. It's also used in economics, religion, and warfare. Okay, after introducing the topic on salts, I would like also to welcome the next presenter to come on to continue with the presentation. Rudi hapa.
I want us to go to the type of salts. In chemistry, there are many different types of salts, ranging from the ones that we use and the other complex one that we don't use around. So, the first type of a salt is an acidic salt. An acidic salt is a salt formed by partial neutralization of a diprotic acid. When we look at this acidic salt, there is a term there known as a diprotic acid. A diprotic acid is an acid that contains 2 protons. That acid that contains 2 protons, it is what forms an acidic salt. And there is partial neutralization. Neutralization is a reaction of an acid with a base. So in formation of an acidic salt, there is partial reaction of an acid with a base to form this acidic salt. The next type of a salt is a basic salt. A basic salt is formed by partial neutralization of a strong base. A strong base is a type of base which has a pH that ranges between 10 to 14, and this strong base has hydroxide ions. The hydroxide ions present in that strong base is what forms a basic salt and is formed through partial neutralization. The next type of a salt is a double salt. A double salt is a salt that contains more than one cation or anion. A cation is a positively charged ion, while an anion is a negatively charged ion. So a double salt does not contain one cation or anion. It contains more than one cation or anion in its formation, so that it can be formed a double salt. The fourth type of a salt is mixed salts. These mixed salts are salts that contain a fixed proportion of 2 salts. These mixed salts are 2 salts combined together in equal proportions, and they are mixed together to bring these mixed salts. These mixed salts, for example, you can say a mixed salt that we use in our normal day-to-day life is sodium chloride. It contains a fixed proportion of 2 salts to form the sodium chloride. So these subtopic types of salts is easier to understand. In summary, I want to conclude on this type of salts. In summary, these different types of salts are essential in our normal day-to-day life. When we consider things like table salt and other types of salts, we use them in most of the activities that we do at our place. So, such as cooking, some salts are used in snow areas for melting the ice that is along the road paths. So this type of salts are important. Thank you. Let me welcome the next presenter to talk on the properties of salts.
Okay, good morning. Today I want us to cover the properties of salts. The first property is the conductivity of electricity. As we all know, conductivity of electricity is due to the presence of mobile ions or due to the presence of the delocalized electrons. So in this salt they have the mobile ions, and the mobile ions will appear only in the molten state of the salt. Different salts have different modes of conducting electricity. Some will conduct at a slower rate, while others will conduct faster due to the number of electrons which are mobile or which can move throughout the molten state of the salt. The second property is the hardness. Salt appear to be hard. This can be attributed to the material or the elements that are forming the salt. For example, we can consider the salt formed by compounds such as aluminium to be more harder than the compounds of elements such as potassium. The other property I can talk about is brittleness. This means that this property is such that the element or the salt is hard to cut. So elements has different properties of brittleness. The brittleness will appear in accordance to the group of the element. For example, elements in group 1 appears to be less brittle than the elements in group 2 and group 3. Elements in the first period appears to be less brittle than the elements in the fourth period. The third property I'll talk about is the crystalline. Most of the solid appears in the crystalline nature. So most of this salt will appear in the solid state, meaning that they will automatically be crystalline. Okay, the other aspect to talk about is the solubility in water. So solubility differs in accordance to the salt. Some salts appear to be more soluble than the others. For example, ammonium salt will be soluble in maybe all of the solvents. Other salts such as the group 1 elements such as sodium, potassium will appear to be soluble in most of the solvents. So the solubility will differ in accordance to the period and the group of the element. The degree of solubility in water will also vary in accordance to the group of the element. Okay, the other property I'll talk about is the transparentness. This means that some of the salt will appear as in a white color, meaning that, or others will appear as a transparent, while others will appear as a black solid, depending on the nature of the elements which are in the compound. In the other one is the odorness. Some of the salt give some odors, while others are odorless. For example, any salt which is coming from a ammonium compound will expect to have a sharp scent, meaning that it is more odor than the others such as sodium or the others. The other characteristics I'll talk about is the taste. Taste can be detected by maybe some of the salts will have different tastes. For example, sodium chloride will have a different taste to the other ones. In conclusion, the properties of salt make it useful in diverse application and various areas. Okay, in addition, there is this one point I was almost forgetting about the melting and boiling point. Different salts have different melting and boiling points. The melting and boiling point, I can say it's different because some of the salt which are constituting the salt, some of the elements constituting the salt have their different melting and boiling points. This makes the salt formed to have either a high melting point or a low melting point in accordance to the salt used to make the compound. Thank you. I welcome the next presenter. The next presenter will be talking about the naming of salts.
Double tap.
Start.
Okay, Oma Juliet, I'm going to take you through naming of salts. And we were told that salts are ionic compounds that are formed by the reaction of reaction of acid with bases, and they always contain either a metal, a cation, or a cation derived from ammonia. The naming of salts is formed based on name of acid by adding name of a metal and including its valency. And okay, it can also be named differ depending on whether salt derives from an oxalic acid or a hydric acid. And we can also name salts based on hydroacid salts end with id. Example is sodium chloride, while names of oxalate end with ate. Example is sodium sulfite. In chemistry, it's common to use customarily to name various salts, and the name of salt consists of two parts, the cation followed by the name of an ion. Here are some rules to follow when naming salt. The rules are, for instance, for fibery ionic compounds, salts composed of two ions, the name of the cation is written first, followed by the name of the anion. Rule 2, for salts that contain metal cation, the name of the metal is used as the first part of the name. And rule 3, for salts that contain a polatomic ion, for instance an ion composed of more than one atom, the name of the polatomic ion is used as the second part of the name. And rule 4, for salts that contain a transition metal cation, a transition metal cation is a metal that can form ions with different charges. So when you want to name them, the charges of the cation is indicated using a Roman numeral in parentheses after the name of the metal. And another rule is group 7 are nonmetals, such as group 7 elements such as fluorine, iodine they all contain a negative charge of 1. And we also have group 6, which are nonmetals, and they begin with oxygen, which they are anions, and they always have the charge of -2, and they can also have the charge of +2. It depends, it's the position of the element on the okay, for instance, for example, the salt sodium chloride is named sodium chloride because sodium, it has a positive charge, is the cation, and chlorine is the anion. And another example is for such as iron 2 phosphate, which is named iron 3 hydrogen phosphate because iron has a positive 3 charge and phosphate has a -2 charge, which is an ion. And we need to know that cations can be composed of one atom, monoatomic cation, or more than one atom, which is polyatomic cation. And we need to be aware that an ion can be composed of one atom, which is monatomic anion, or more than one atom, which is polyatomic anion. The name of salts, as I said earlier, we start with the name of cation followed by the name of an ion. The name of every salt consists of two parts. The first part comes from the metal, and the second part comes from an acid. In summary, the name of salt is determined by the cation and anion it contains. The cation is named first, followed by the anion. There are specific naming rules for cations and anions, and it's important to follow the naming starting from a cation, then following an ion. And I want to take a note that there are some exceptions to these rules, and some salts have common names that do not follow these rules. Okay, I want to welcome the next presenter to tackle on hydrolysis of salt. Thank you.
So I'm going to talk on hydrolysis of salt. So hydrolysis of salt refers to the reaction of salt with water. It is the reverse of a neutralization reaction.
So salt hydrolysis is also a process that occurs when salt is mixed into the water and the water breaks the ionic bond, resulting in either acidic or basic aqueous solution. So when we are talking about salt hydrolysis, when we talk about salt, the first thing that comes into our mind is white and soft crystal commonly found in a kitchen to give a taste to food. So in chemistry, salt is an ionic compound resulting from the reaction that neutralizes the charges of an acid and base. So there are three types of salt based on the pH level. The alkali salt or basic salt. So alkali salts are salts that will produce hydrogen ions when it reacts with water in a salt hydrolysis process. So this type of salt is a base that is formed from a strong base and a weak acid. Examples of alkali salts are sodium carbonate, sodium acetate, and sodium hydroxide. Acid salts will produce hydrogen ions in a salt hydrolysis. So some salts form basic solutions. When solid sodium fluoride is dissolved into water, it completely dissociates into sodium ions and fluoride ions. So the sodium ions do not have any capability of hydrolyzing, but the fluoride ions hydrolyze to produce a small amount of hydrofluoric acid and hydroxide ions. Salts that are derived from the neutralization of a weak acid by a strong base will always produce salt solutions that are basic. Some salts that form neutral solutions. So a salt that is derived from the reaction of a strong acid with a strong base forms a solution that has a pH of 7. An example is sodium chloride formed from the neutralization of HCl by sodium hydroxide. A solution of sodium chloride in water has no acidic or basic properties, since neither ion is capable of hydrolyzing. Other salts that form neutral solutions include potassium nitrate and lithium bromide. So salts are formed from salt solution. When you take a strong acid and a strong base, you will form a neutral salt solution. And when you take a strong acid and a weak base, you will form an acidic salt solution. When you take a weak acid and a strong base, you will form a basic salt solution. So salts formed from the reaction of a weak acid and a weak base are more difficult to analyze due to competing hydrolysis reaction between the cation and the anion. These salts are not considered. So these salts are considered due to the competing hydrolysis. So in summary, salt hydrolysis is a reaction in which one of the ions from a salt reacts with the water, forming either an acidic or basic solution. The salts that are derived from neutralization of a weak acid by a strong base will always produce salt solutions that are basic. And salts that are derived from neutralization of a strong acid by a weak base will always produce salt solutions that are acidic. And lastly, a salt that is derived from the reaction of a strong acid with a strong base forms a solution that has a pH of 7. So let me welcome the next presenter to present on preparation of salts.
So I am going to continue with the next slide, that is preparation of a salt. So okay, the definition of holds an important clue to how we can prepare salts in the laboratory. So I'm going to discuss some of the ways or some of the methods of preparing salts. So there are almost 6 ways of preparing the salts. So what I can say here is that the method chosen for preparing a specific salt may depend on the solubility of the salt in water. So I'm going to prepare or to discuss how to prepare soluble salts. So the first method of preparing a salt is by reacting an acid with a reactive metal to form salt and hydrogen gas. So for example, when reacting zinc metal plus sulfuric 6 acid, so it forms zinc sulfate plus hydrogen gas. So that is a reaction of an acid and a reactive metal, that is zinc. So what I can say here is that zinc is reacted in excess, and that reaction of acid in excess is to ensure that all acid reacts completely in the acid. So in a reaction, it will form a saturated solution when you react that acid and a salt. So it will form a saturated solution. So in a solution, you will allow the solution to cool for zinc crystals to form. Zinc crystals, so zinc sulfate is now the salt that has been formed by reaction of zinc plus sulfuric 6 acid. So you allow it to cool, then so the process of obtaining a salt crystals from a saturated solution by cooling is called crystallization. So other salts can be prepared by the same method, magnesium nitrate, that is reacting magnesium and nitric 5 acid. Another one is zinc chloride, that is reacting zinc metal plus hydrochloric acid. Another one is reaction of calcium and hydrochloric acid to form calcium chloride. So the next method of preparing a salt is by reacting an acid with carbonates to form salt, water, and carbon dioxide. So for example, preparation of lead-2 carbonate. So lead-2 carbonate, or when lead-2 carbonate is added to the warm nitric acid, in that preparation, warming speed up the rate of reaction. So when you react lead-2 carbonate plus nitric 4 acid, it will give you, or it will form a salt which is lead nitrate plus carbon dioxide plus water. So another example of preparing a salt using acid and with a carbonate is that when you react calcium carbonate plus hydrochloric acid, it will give you calcium chloride, which is a salt, plus carbon dioxide plus water. Then next method of preparing a salt is by direct combination of a metal and an acid. So what I mean is that reacting a metal and a non-metal to form a salt. So this method is used to prepare both soluble and insoluble salts. So for example, reaction of iron and sulfur to form iron 2 sulfide. So iron is a metal, sulfur is a non-metal to form iron 2 sulfide. So this method is called the direct synthesis. So other examples are when you react sodium and chlorine, it forms sodium chloride, which is a salt. So the last method of preparation of a salt is acid undergo neutralization reaction with bases. So I mean that when you react an acid with a base, so for example, potassium hydroxide, you add nitric acid, it will give you potassium hydroxide, potassium nitrate plus water. So that is, or those are the methods of preparation of salt. So I would like to welcome the next presenter to take us through the video on preparation of salts.
Unajua tu hapo. Apoteza time hapo.
From the video, we have seen the laboratory demonstration of how we can prepare different types of salts. For example, preparing salts like zinc sulfate, we add the desired amount of zinc metal. The amount of zinc needed will depend on the desired concentration of zinc sulfate solution. Dissolving the zinc, place the white zinc metal in a beaker and add a small amount of sulfuric acid. Stir the mixture to facilitate the reaction between the zinc and sulfuric acid. This will produce zinc sulfate and hydrogen gas. After the initial reaction has occurred, add more sulfuric acid to the beaker to ensure that all zinc has reacted. Continue to stir while the mixture. Gradually add distilled water to the beaker while stirring to dilute the solution. The amount of water you add will depend on the desired concentration of the zinc sulfate solution. If there are any undissolved impurities or salt residues, you may need to filter the solution to obtain a clear zinc sulfate solution. Use appropriate testing method to determine the concentration of the zinc sulfate solution. Adjust the concentration by adding more water to zinc sulfate as needed. Once you have the desired concentration, transfer the zinc sulfate solution to a suitable container and store it for your intended use. It is important to note that working with sulfuric acid and chemicals should be done with caution, and proper safety measures should be followed. Additionally, the specific quantity and concentration will vary depending on the intended application of the zinc sulfate solution. So I will welcome the next presenter to take us through the consideration on salt production.
The consideration on salt production. Consideration number 1. Is the salt product soluble? Yeah, in this we are going to consider on the source of the salt. Understanding whether the salt harvested from salty water, e.g. the sea salt, or mined from underground salt deposits, or the rock salt, affect the production method. Consideration number 2 is the extraction techniques. Different methods such as solar evaporation, vacuum evaporation, or solution mining are used depending on the source and desired product. The other consideration is the purity level. The purity of the salt can vary, and production may involve refining to achieve specific purity levels for various applications. The other consideration is the environmental impact. Salt production can have environmental consequences like soil and water salinity. Sustainable practices are essential to minimize these impacts. Other consideration is the energy usage. Some production methods require substantial energy input, like evaporation processes. Energy efficient technologies can reduce costs and environmental impact. Measure number 6, the market demand. Meeting the demand for different types of salts, like the table salt, industrial salt, road salt, and others, requires understanding market dynamics. I will welcome the next presenter to present on the uses of salt.
I'm going to talk about the uses of salts. Here are the list of important salts and their uses. For example, the salt number 1 is sodium chloride, or common salt. Sodium chloride has various uses. For example, sodium chloride is used in cooking food as well as cooking gas. It is also used as a preservative in pickles and in curing meat and fish. It is also used in the manufacture of soap, used to melt ice in winter and cold countries. It is used for making chemicals like washing soda, baking soda. Another important salt is sodium hydroxide. Sodium hydroxide has various uses, like it is used for making soap and detergents, used for making artificial textile fiber. It is also used in the manufacture of paper. It is used for purification of bauxite ore. And lastly, sodium hydroxide is used in degreasing metals, oil refining, and making dyes and bleaches. Another important salt is sodium carbonate. It's also known as washing soda, hydrated sodium carbonate. Hydrated sodium carbonate has various uses, like it is used as cleansing agent. It is used for removing permanent hardness of water. It is used in the manufacture of glasses, soap, and paper. Another important salt is calcium hypochlorite, or bleaching powder. This salt has uses. It is used as bleaching agent in cotton industry and paper industry for bleaching cotton and linen, as well as wood pulp, respectively. It is used for disinfecting drinking water, used for making chloroform. It is used for making the wool unshrinkable. I welcome the next presenter. To present on the applications of salt.
Let us look at the industrial application of salts. So we'll start by the cleaning and safety applications of salt. Number 1, we have got manufacture of detergents. So salts are being used to manufacture the detergents. When several chemicals are present, salt separates the chemicals so they can perform their specific tasks. Then we can also look at the chlorine production. Like sodium chloride is mainly used in industrial for the production of chlorine. Then we have got the pool maintenance. So we can use sodium chloride and other salts to maintain the pools. So instead of using chlorine, we can use salt to maintain the pools. Like we are now cleaning the pools using the salts now. Then we have got road maintenance. So salts are being used in areas where we have got melting, so that we can control the ice or melting of the ice in the road. So we apply the salts on road to maintain the roads. Then we can go to manufacturing. So salts are being used in pharmaceutical to make drugs. They are being used to make drugs such as capsules. Salts, in making the capsules, they act as the raw materials. Then we have got another use of salts in chemicals. Industrial salts eventually become caustic, sodium, soda ash, sodium sulfate, sodium carbonate, sodium hydrochloric acid, sodium bicarbonate, and chlorine, to name a few. Then oil and gas drilling. Salt increase the density of drilling fluids and soil, which increases the safety during the drilling process. Salt behave as both coolant and lubricant for drilling heads. Industrial salts also expense concrete drying and act as flugants to remove the impurities. So we can use the salts to make in the manufacture of oils and gas drilling. That will mark the end of our presentation. Thank you for listening.